let me go back. Sorry. Okay, so yeah, I meant to share this then. So it's just like a quick, I think it's like 3 slides or something. But anyway, they're just like a one slider. And so this is like mostly about Altair. So this is what I mentioned already. We're in 86 different countries, founded in 1985 in Troy, Michigan, where I sit. I don't live in Troy, but I'm 15 minutes from the headquarters. So that's where my home office is. It used to be back in 85, it was 2 softwares. Now we have over 150. A lot of them, students can get free versions of. And the cool thing is we develop our own software, but we also have a partner software um, program where other smaller vendors are basically included in our licensing. And so if you want to use like Encode or like a fatigue solver or other different solvers, it's included in our licensing plan. And when we pay that company a small commission or whatever, if you guys use that, so it basically broadens our portfolio. We have a bunch of different customers. I'm in the automotive vertical, basically what I mentioned. So a couple of these names are my customers, but we're basically do a little bit of everything. Like I mentioned, we're doing a bunch of data stuff now, machine learning and AI. And so we have a bunch of financial services customers. But my home being in Detroit is automotive. And this is where I was mentioning, I believe it's Altair University or university.altair.com. I can't remember that I can't remember the URL off the top of my head, but I could probably find it quickly, or just open a web page. But we have a bunch of different free softwares that you can download as a student. Like I mentioned, use your .edu email to create a quick account, and then in many cases, where is it? Wouldn't be here. Industrial and design, multi-physics. Considering 1D like system modeling. If you do any Compose or Simulink, MATLAB or Simulink, we have tools that are comparable to those that are free for students. So anyway, that was my kind of quick spiel about Altair. See, Christopher raised his hand. Feel free to unmute and ask any questions or interrupt me.
Yeah, I have a quick question regarding how much, like, if we get the full version of the softwares they're talking about, like the solid analysis, or is it more like a student version where it's like restricted on mesh size?
Let me see here. I'm gonna go to website here. So it looks like I just put in Altair University and this popped up. But I believe, let's say I were to go to, I know some of them in the past used to have like mesh size restrictions. Let me go here. Let me click here. I thought there was a breakdown of what you're able to, that you could click these and take a look at there. Some of them might have mesh size restrictions, but I know some were just brought up, like the system modeling, control and robotics one, I believe is the full version now, a tool called Inspire. I have to check on that. I believe there might be some restrictions, like 500,000 elements or something.
Okay.
Yeah, I believe there are some restrictions. But this is where you would go. Yeah, just put it in Altair. And it was, yeah, so I just clicked the first one, student edition. I click students. Hit the free student edition. Okay, it brings you here. It's the same thing. So yeah, basically, I think you would, here's the create an Altair One account with your EDU email. It'll give you a licensing key. I think it's actually just online licensing now. So you just connect to the internet and the license is, somehow it activates your computer. Or it pulls your MAC address or something. And then it'll bring you to a page where you can download the different softwares that are available. And then you just install them. So from more about student editions, maybe it's right here. Okay, so This is licensing. What can I do? Product limitations. Activate and compose our Simulink and MATLAB, and then embed is another systems. SimLab is another tool similar to HyperMesh. If you're familiar with HyperMesh, it's a finite element pre-processing tool. But SimLab, you could pretty much do anything, and I'll show that today when I do my little demo here in a second. So it looks like HyperWorks and these softwares might have some restrictions. OptiStruct and Radios, 100,000 nodes. So yeah, it looks like there are some, depends on the software you download, but it looks like there are some restrictions, some not. SimLab has the software, the solvers baked into it. So you only install SimLab and you don't have to install the other solvers, like the other Altair solvers. So this might be a way to get around the size restriction. So anyway, that being said, let me pull up SimLab and I can start kind of talking about this a little bit. So this is the SimLab interface. SimLab is our industry leading multi-physics platform. I started using it a lot. It was initially developed. I have some transmission and axle customers, and traditionally SimLab was developed. We acquired it probably 7 or 8 years ago, I think. It was under another name, but it was developed for powertrain meshing, so large cast components. Think of like a transmission housing, big aluminum cast component with a lot of ribs and holes and things. SimLab was its kind of key feature was its really, really powerful 3D meshing capabilities. So creating 3D elements was its strong suit, but we've turned it into a multi-physics solution. So on the left are your assembly browsers. Sometimes you want to see the output window. I think I happen to have that popped up. Basically, your assembly browser is going to contain most of the model that you create. So your CAD that you might create or import, and any mesh that you create. And then there's solution browsers and these different containers for other things. All the tools that I'll use to actually create or mesh or create boundary conditions are going to be up at the top here. These are all called ribbons. So mesh, geometry, analysis. If I get this zoom thing out of my way, if I just click away, thought there was a way to hide this. It's kind of blocking some of the screen. That's okay. I can deal with that.
Sorry. Is there any way I can help you? Something is getting blocked. Is it from my side or yours?
No, it's just a little menu bar at the top. It's kind of blocking some of the
Oh,
ribbons,
okay.
but it's okay. I can.
Okay.
I thought there was a way to like minimize it. Usually we use Teams, like Microsoft Teams, and sometimes I use Zoom. Some customers use Zoom, but so I rarely use it. But I forget if there's a way to minimize the sharing screen, pause, share, annotate, that sort of stuff at the top.
Oh, okay.
It's not a big deal, but thanks for asking. I think I have all the permissions I need. What I can see here, what it's not blocking is my solutions ribbon. Like I mentioned, it's a multi-physics software, so we can create all these different solutions, whether it be a structural solution, so a static stress solution. In my demo today, I'll use the dynamic stress. If I were to click here, I can create like a normal modes analysis or direct frequency response, modal frequency response, all these different linear dynamics, even nonlinear transient solutions. There's thermal, there's flow, electromagnetics, specific electronic solutions, battery solutions that were just added, I believe, late last year, e-motor, drop tests, so even some explicit solutions like, dropping a phone on the ground or, maybe hitting a power tool with a rod or something, see if the effects of impact, whether parts will fracture, fatigue, and the list goes on, even optimization. In a lot of cases, you can actually couple these different solutions too. So, like a structural thermal solution. You can run a structural solution and then couple that with your thermal solution, or vice versa. So heat the part up and then try to bend it and see if the thermal effects change the result of your structural simulation. So what I'll do here is talk a little bit about how you might create some CAD inside of SimLab. I don't know if you guys have access to NX or anything. If you were to draw something, you could bring in a model to SimLab, but you also have some capabilities to create some kind of dummy CAD inside of SimLab, or also 1D representations of a bar beam. So I'm going to go to the geometry ribbon first, and I'll click create body. So if I wanted to create, let's say, a generic shape like a cylinder, a window would pop up, and I can orient this cylinder. I can actually create a CAD or directly create a mesh. So if I were to create a mesh, I could change this to a TET form mesh. So it's a solid first order mesh, and then I can change the size of it and change the mesh parameters. In this case, maybe I'll just create CAD. Right now, by default, I have the height, or in this case, I would call this my length, is 1,000 millimeters, and then because I'm creating a cylinder, the outer radius is 5 millimeters. So if I were to click OK, I can directly create some CAD here. Oops. Create this cylinder. And if I were to go back to my assembly browser, I were to drag this over, we can see the cylinder. I can turn it on and off. And I could go to the mesh ribbon and actually tap mesh this, solid mesh this, or surface mesh it, depending on what you want to do. So let's say I were to put in 10 or something. Maybe I should put in 10. Click apply, and I could just mesh this, or like I mentioned, I could directly create a mesh from that cylinder ribbon. I can mesh this cylinder and then start creating a solution. Also, if I wanted to create a 1D representation of this, I could also go nodes. I could create maybe some nodes in between, maybe at the end of this here. So I create a node there, kind of a dummy node. Create a node here. And if I were to hide my cylinder, I could use a tool like go back to geometry. I could create an edge between two nodes. Back in my geometry ribbon, I could click this as my start node, that is my end node. And then I could put in number of elements, number of beam elements I want. Let's say I wanted 20 elements in between these two nodes. Click OK. And now you see I have this beam element, or 20 beam elements. So you can see there's kind of a small slit. I'm not sure if my resolution on my screen is too high, but on my screen I can see there's some small slits in between. And if I wanted to, I can unselect this, and we can see I could select a node here. I can select these nodes in between the 1D elements. So those are a couple options for creating bodies inside SimLab. You right click and deselect the nodes and everything that I've created. If we see here, I have a cylinder, a CAD cylinder that I've created. It says cylinder CAD 1. If I were to show it, this is in a different assembly as my mesh, my 3D mesh, I should say, because my other wire body is the 1D mesh. And then you can see the third, I guess, component that I've created, this 1D mesh, is in another container. If I wanted to combine all of these, I could drag my cylinder into, oh, I can't combine that with an FE body. I could probably combine these two into the same container because they're FE, but if I wanted to, I could drag this into this body or this container if I wanted to, consider them in the same analysis. So I actually have a model here. It's already meshed. In this case, we have 1D elements. Next thing I might want to do is create maybe a property or apply some material to this. Because for any sort of structural analysis or modal analysis, vibration analysis, we need a couple things, right? We need some elements. We need to apply some materials, some material properties. In the case of 1D beam, we have to apply some cross-section, cross-sectional area. And then we'll actually set up the solution or the load case. So I'm going to move from my assembly browser to this property browser. I'll put this here. And we see there's a bunch of different kind of objects in here. So we have some materials, or kind of drop those down. Then we have properties down at the bottom. If I right-click properties, I can say create, and a window will pop up. I have a couple different options. So if I were to create a property for the solid 3D mesh, I might use this solid entity type. In our case, I would use a solid type, a solid property. And if I was doing a CFD solution, I might use the fluid, but in this case, I might use solid, and as a linear run, I would use like an isotropic behavior, and I could select my material. In the case of the 1D beam here, I would probably, or I should switch this to the bar entity type, and then I'll switch this to a beam. And like the solid property, I can apply some material. In this case, I could pick steel here. If I wanted to change those material properties, I would modify them here. But let's say I'm okay with generic steel material. I could select that and then actually define my cross section. So in SimLab, if you create a beam property, you have all these different section types you can pick. So I could pick a rectangle. In this case, kind of mimic the 3D elements that I created. My cylinder. I'll click this circle 2. We also have circle 1 if you wanted it in. I wanted a hollow tube or something. But I'll pick this cross section, and I can put in, let's see, 10, and actually 5. Put in 5 because my other radius was 5. Click OK. And you can see I can't click apply or OK yet. I have to actually select something that I'm applying this property to. Maybe I should name it. I'll call it beam or 1D beam. So once I select this part, I can click this. Now I can either apply and create another property or click OK and close the window. So I click OK. And now my property has been applied. We can see a property has been created. And I've applied it to this set of 1D elements, these 1D beams. If you notice, I've been selecting different things, nodes, bodies. On the left over here, and if I right-click, there's also the similar options in my right-click menu. These are all different types of entities I can select, I should say. So if I had a corner or a point, I could select a vertex, different types of lines. So let's say I had a bunch of circles I wanted to select. I could pick a single edge or a circle. It'll identify circles, edge paths, free loops. This is faces. If I wanted to grab the inside of a cylinder or a fillet, I have different selection options. All these are different entity types. This one, I think, is the default, I believe, and this is the body entity selection. And if I were to click the beam, But you can see I get a representation, kind of graphical representation of the property that I've applied to the 1D beam. So I select the body being all 20 elements that I've created here. If I go back to my assembly browser, you see it's called wire body 1. That's all my 1D elements. If I were to drag this to the right, we see I've applied the steel material. And when I click it, I can see the actual kind of graphical representation of that cross section that I've applied. To take one step back, if I were to double click steel, or to just double click the name, I can come in here and I can change the material properties of the steel. And when I change these, I click OK, it will ask me to I think update the property. Let's say I had a a brand new material. They call it Paul's material. It's something that's not in SimLab by default. We have a couple of materials sitting here. If I were to go to analysis and click, I believe it's this button here, a brand new material will be populated. And I can call this Paul's material. And I can, just like the other, I can change the category of the material, the class, which will give me different options to put in if it's hyperelastic, or maybe a gasket or rubber. In this case, I'll create a metal, isotropic material, and then I can go in here, modify the properties. Once I click OK, you'll see Paul's material will populate over here. And if I were to click the body, I have another option to apply the material. I can't do anything about the property from the right-click menu, but if I were to right-click here, I go to material, I can change it to Paul's material here. Because I've already applied a property, it wants me to do it through the property. So if I were to go here, I have to change it to Paul's material. It's going to ask me if I want to update it. I'll click yes. But if I had a solid part, let's say I were to go back to my solid beam that I've created, I could click this, right click, change this to aluminum, select it, right click, and then change that to Paul's material. I already have material assigned. Do you want to overwrite it? Yes, I do. So you have an option specifically for, I guess, solid bodies or probably shell bodies as well. You can apply it directly from the right click menu. In this case, I'm going to keep going with my wire body. So we've created the mesh. In this case, 1D elements. I've applied a property. So SimLab, or in this case, OptiStruct will be the actual structural solver, the solver doing the math in the background. I've applied the property, so OptiStruct knows what material this beam is made out of, right? It knows how this should perform based on how stiff this beam is and everything. So now the last thing I need to do is create a solution. So just like I showed earlier, if I go to the solutions ribbon, I can click structural solution. If I go to dynamic stress, I have this window that will pop up, and I can change my solution type from normal modes to anything in this list. In this case, I'll click normal modes. Excuse me, wants to select a body. I can only select bodies from the same assembly. So if I had multiple bodies inside of this wire mesh 1.gda assembly, I could select individual bodies or select the whole thing. In this case, I only have one. So if I were to select my beam, this is the body that will be analyzed in this solution. If I were to click OK, you'll notice it switches from my assembly browser to my solution browser, and my normal modes analysis has been created. So now, also, one thing that has changed is it's jumped from the solution browser to the analysis browser. And the analysis browser is where I created the material. One thing I didn't mention is if I were to click this little icon down here. If you notice, these tools have multiple, I guess these icons have multiple tools inside. So this one's material. If I were to click this material database, this is SimLab material database. And so we have some different generic materials. If I were to double click, if I wanted to, add one of these, say asphalt, I could load that to the material browser, and then use that in one of my analyses. So here's some kind of pre-baked materials. These are already in here that you can use. Just wanted to mention that just in case you wanted to poke around in there. But basically, my analysis ribbon is where all my boundary conditions and loads are applied. So if I wanted to, I could directly run this, right? I can run a free modal analysis. So if I wanted to, I could do that. All I have to do is right click and update this. So if I right click update, this will send, this will write out an OptiStruct file, and this will run the model, and then the results will populate inside of SimLab. So I've already changed so I can already look at in this case, this is the 10th normal mode. My first 6 being unconstrained are going to be rigid body mode. So if I were to look at the first mode, 7, I can look at this mode shape. And if I wanted to, I could change this to make it a little bit smoother. So I can directly run the solution being normal modes here. If I wanted to, I could right click here and duplicate this solution. Let me right click and hide the results. Now that this one is bolded, this is the current solution. So if I wanted to, I could also add, let's say, a fixed constraint. So if I wanted to hold the end, let me change this to nodes. I want to select a node. I could select this node, maybe that node, or whichever node you'd like to constrain. And then if I want to freeze those degrees of freedom, I have all these boxes checked. If I wanted to allow motion in, let's say, the Z direction, I could uncheck this box. In this case, I'll fix all 3 degrees of freedom. Click OK. And so now I have a little green icon here. It's kind of small, and I don't think I can make it any bigger. Those are the graphical representation of my fixed constraints. If I had multiple parts, I could create contact between the parts, add a concentrated mass. Let's say there's a concentrated mass in the center here. I could add a mass, which would definitely change my natural frequencies, as well as, add connectors to connect different parts together. In this case, we have one part, so stick with this. One thing I want to mention also is you'll see the solutions created over here. My solution type is normal modes. If I were to double click mesh, this is where I can select additional bodies. Let's say I were to mesh another part, I wanted to add it to this analysis. I can select that additional body here, but this is helping me verify that I've selected my 1D elements for this solution. Click OK. That's the way it was set already. And if I right click settings and I go to solver settings, we can see some of the solver cards that I might want to check or things that I might want to change. So in this case, we're using EIGRL. This is a normal modes extraction type. What's probably more important for you guys is the number of normal modes that I'm requesting. So if you want the first 10 modes, you can put in 10 here. If I wanted to request 100 different mode shapes, I could put in 100. Or I could uncheck this and I could go from, I want to know the frequency range 1 to 1,000. I could specify, give me all the different modes that are between 10 and 1,000 here. In this case, what I'll do is I'll just leave it like this, click OK. You'll see solver settings. If you change the solver settings, it'll populate here. And just like I did before, I'll right click and update. And in a few seconds here, I can take a look at my different normal modes or my different mode shapes that are populated. So now that I've constrained my model, it's still pretty low. Let's go up this one. So I can look at these, click play to animate. And if I wanted to record this and put it in a PowerPoint presentation, I have this option here down at the bottom. Play the animation and record it to MP4. Is there any questions so far? Anything I should go back and talk about? I know I've been kind of going on for a little while. And check what time am I at? Going for about 40 minutes. So there's no. So I don't believe Altair has put any SimLab videos on YouTube specifically. There might be videos out there online somewhere. But what I would recommend doing inside of SimLab, if you go all the way up to the top right here, there's the SimLab Learning Center. And if you were to click this little book icon, it'll pop up this web page, web.altair.com/Altair for SimLab Learning Center, whatever the URL is. If you come here, you'll notice on the left, there's a bunch of different SimLab tutorials. Each of these tutorials, so if I were to go to structural normal modes analysis break assembly, there's a video link and a model I can download. So if I wanted to, I could watch the video, click this video. This wants me to download something. Cancel. So probably have me do the same thing. Okay, so it's gonna want me to download the zip file, and it will contain, I guess, the video and the model. So the model is something you can follow along the video with. So this has all kinds of different solutions in here. It has meshing help, editing connections, post-processing, automation. So this has almost everything you need inside of this web page. So this is I find this to be very useful. It's something I point most of my customers to when I do a SimLab training. And that's just up here, SimLab Learning Center. And then if you want, you can also go File, Help, SimLab Help. I believe it's a local file. I don't think it's a web page. So it's something that this might look different depending on which version you have. 2024 just released recently, so I'm not sure if you might have 2023 or 2022 version. Or if you might have recently downloaded, it might be 2024 already. But inside of here, you should also have some help. So structural and thermal loads and, some other different things you can go through. So let's say we're to go to structural and thermal loads and constraints, fixed constraints. It has pictures and things. So this is also something you can do. See structural, circular, linear, static. I haven't played too much with the help. I prefer to go to the learning center, but that's also an option. If I were to go to, let's see, or just go YouTube. I don't believe we have any SimLab. Lab. Yeah, it doesn't look like anything. Let me go Altair SimLab. Okay, so there's some Altair Global Academy or academic program. So there's some. So it used to be SimLab ST, Solid Thinking. So it looks like there might be some videos up here. I wasn't aware that they had much up here. For some of our other tools, we have playlists that are up there. We actually have an Altair how-to website. So let me click this one, Learn All Analysis with SimLab. Pause this. So there's a bunch of different videos in here. Nonlinear snap fit, quick quasi-static, quick static analysis, mesh conversion study, modal analysis of a compressor bracket with SimLab. Okay, so I guess I stand to be corrected. That was wrong. There are some videos on SimLab or on YouTube of SimLab. quick modal analysis of a circular beam. This looks very applicable to what you guys have to do. So, yeah, I guess if you do some searching, it's out there. So, I guess that's a good question. Any other questions? Anything you want me to go over again? I know I might have went quick through the, I guess my demo.
For our project, I think we were told to do like damping and see the frequencies. Are we able to do it on here?
Yeah, so if I were to, that's a good question as well. So let's say I were to double click steel or Paul's material. I can apply a material damping coefficient here. So if I were to put in 0.5 or something, click OK. Gonna get rid of my solution or my results, I should say. I'll click yes. I want to override the material sign, yes. So then I could rerun my material. I could rerun my analysis with this damping coefficient added, material damping. And so that again is if I were to go to my material or my property browser, and then depending on which material, if you create a material or you have, you're using the generic steel, you double click it. And at the bottom of the elastic properties is damping coefficient. That's a good question.
Okay, thanks. And what about like seeing the frequencies
So
when
let's
damping
go.
properties are applied?
So let's say I were to right click and update this. So let me rerun the solution. Okay, so it's done already. So all my frequencies here, let me see, is there a way you can get a table of them? I don't believe so. So all my frequencies are listed out here. In this case, this was my unconstrained run. So my first 6 are all rigid body motion. And then my 7th, 8th, 9th, and 10th mode are my first couple dynamic modes. So there's the first one. In this case, it's in scientific. So this is 45.47 hertz. So 45, this one's 45 point. It's pretty close to each other. One must be in like X, one must be in Y.
So, Paul, if I may ask, this is in hertz, not in radian per second, right?
This is in hertz, correct?
Okay, because I just want to let the class know that's the other software, they usually give it to you in radian per second. I also have a question, Paul. Is it possible to see them directly from the analysis? Is it an output file? What's the name of the output file? .out or something
So if I
else?
were to go right click the results, that's a very good question as well. Open results folder. So if I were to go to this result folder, and there is a .out file here. So OptiStruct
Okay.
outputs the .out file. When I were to open that Notepad++, and then, or Notepad or whatever, I can
Yeah.
go all the way down
Okay,
to the
yeah.
bottom of this, and
You have it like
I
a
have
list.
I have all my frequencies, eigenvalues. So this would be my final. These are what the values that I'll see in
Yeah, so
SimLab.
this is um, and if the student wants to get, because this is the first time they're doing something like that, to get rid of the free the negative 0.5, is there a way you can tell the system, maybe this is a bit too advanced, a little advanced, it's not really too advanced, but you can tell the system to ignore these frequencies because you don't want to see them. These are like the zero. Zero is not a real frequency. So it's like 5.68, the first one. It's all negative 0.5. Is there a way you can suppress these, tell the system you don't want to see them, or that will have to go to the bulk data input? We don't want to go there. It's not like we want to go there. I'm just asking, is it more sophisticated, or it's been a while I haven't done these, so
So if you wanted to, so if you constrain the model somewhere, so like in my second analysis here, or to update this one, if I add a constraint, my first normal mode will be higher than 0, or it'll be, so my first, let's see, my
Yeah.
first one is, I don't know why it's e to the -4, but this one, I guess one's still low.
Yeah, these are they shouldn't be, but remember this is hertz.
Right. So this one, so if I wanted to, I could double click solution settings and I could say, instead of requesting 10 modes, I could say I want all the modes between 1 and 500 or something, so that I get rid of
Okay,
the,
okay, yeah, right. You can
I
get
get
rid
rid
of
of all
the
those
or
0
yeah,
modes. Click OK. It's gonna see, it's gonna
suppress
get rid of my
those.
solution.
Okay,
Yeah, so then I should be able to update this and get everything between 1 and 500.
very interesting. Yeah, this is a
And now I
much
have
better. Yeah, for the students to see things better.
1,
Okay.
2, yeah. So now my first mode is 20 hertz.
Yes, yes. You have, yeah, and the second mode is the same magnitude but different frequencies because
Right,
they are in different directions. This is something I like to emphasize to the students to realize that what they're doing. That's just because it's symmetrical.
right. You'll get first order bending, and then it looks like another first order bending.
Yeah.
And then a lot of times you'll get second order, first order torsion.
Yeah, first order, second order. We went over it in class. I didn't really give it the name first and second order, but pretty
Okay.
much.
So yeah, in this case, it looks like what you'd want to do is click those solution settings or solver settings, I guess we call them, and then change it from 1 to 500 or something. And looks like this gave me about 8 modes. So if you wanted to increase this slightly, you can get. I don't know if you're asking them for a specific number of modes, or you want to look at the first 2 or
Yeah,
3.
I told him that the first 5. I don't remember. I asked him for the first 5 or 10. I can't remember. I have it in the assignment. But
Okay.
yeah, it's probably asked them to the first 5 because usually in the industry they don't really expect you to match the last 10 or something, or they like above 5. I kind of
There's
wanted
a way
just
to
to
output. I'm trying to think if there's a way to output in radian per second. Um, that I might have to
yeah,
get back to you on.
you
I'm
can
not
just
sure.
let
Can't
them
remember.
play.
Yeah.
Yeah. But the solver gives it to you in the data that you showed me, the output file that you showed. I was
Right.
going to, I thought that it should give it to us in radian per second because that's like the interface will give it to you in whatever you want. But in the
Uh-huh.
solver, I thought that the solver will give it to us as an output should be really in radians per second. That's my expectation. I don't know if it gives it. Maybe when you set the analysis, you ask us to give it to you in hertz. I'm not against it. It's either one or the other. It's just I don't want the students to be confused. I want them to be aware of what they're
Yeah. In this
when
case,
they're
it definitely
solving. They
is
know what they're
hertz
doing.
when it's output. There might be a way to change it, but in this case, for sure, it's the output default output is hertz for sure.
Yeah. The default. Okay, yeah, that's fine. Okay, well, Paul, thank you very, very much. We kind of stretch it for you. Um, I am very, very happy with this presentation. Thank you very much. It's clear. Although the students may not necessarily, because this is the first time they're seeing it. Maybe some of them already have experience with other software. I don't know if they've played with other software, but this is really great. I really love Altair products. I never worked with them myself, but from the first time when I saw how the meshing worked, it was very, very impressive. And later on, when between actually, I think the last time it was it Eric who gave us a presentation.
Yeah, I believe it was Eric. Yeah.
It's amazing that the solver does many other things one shot. I'm old school, so I've gone through even XL, capital X, capital L, Unix system, Patra, rather Nastran, and later on I worked with Patra, Nastran, Linux, and later on PC versions.
Hmm.
So I've gone through everything in FEMAP. I worked with FEMAP and ANSYS as well. ANSYS very little, but most students work here with ANSYS, though we have NX Nastran. I never touched NX Nastran. I tried, I just didn't know how to use it because it's SolidWorks and it's been a while. I haven't done even AutoCAD. So, but I was very, very impressed by it. And I just don't want to demean the others. I think the others also have new, like Dynamica and other stuff. But all in one, what I've seen here, the presentation between you and Eric was really, really fantastic what your product does. And I wish I could play with it. I did actually get a copy from
From Darius, maybe.
They're from Darius, yeah. But
Hmm.
I installed my laptop, which kind of crashed. So I'm going to be, although mine is a gaming computer, but I will be having it in my school. It all depends whether they want to allow me to use it or not. I don't remember the version, but I'm not allowed to have student version in my computer. It has to be. Yeah, we have some restrictions, really, and they're very, very strict about a few things. Even when I purchase something, software, they want to see the invoice, they want to see what I've done, where did you purchase it from. And the other day I got Mathematica, and they asked me, how come you have two versions, one for the laptop and one for my computer, and they asked for everything.
No.
And so they're very careful, and I don't blame them. I am very happy we have something like that. But anyway, thank you very, very much, Paul. I hope the students will got entertained by what we have here. I thank you on behalf of the students as well. Thank you, William. I hope to
thank
see you or to talk to you again, maybe next semester or so, or maybe even this semester.
Yeah, thanks. I mean, yeah, thanks for having me.
Thank you.
It's nice to have. Definitely, I've used SimLab at Wayne State, my local university, because everything, the professor that I used to work with liked that everything was in one interface. You don't have to go back
Yes,
and forth
yes,
between
exactly.
stuff.
Yeah, yeah. And
So yeah,
once you know
definitely get
one
a hold of.
software, it's so easy to just adapt to the rest within the same software, like you said.
Right. Yeah. This shares the same interface as three to five other tools that we have, and we're trying to get it all in this one interface. So it's nice so you can bounce between them. So yeah, it'd be great to come back. Let Darius know if you need any help in the future. Yeah, guys, email him and
Absolutely.
we'll get something going. Well, thanks
Yeah,
again
I
for.
think we're going to be continuing with this. I'm very, very impressed. Yeah, I like you guys. I like the team. I like the software, though I never worked with it, but I do have some students who are working with me on it. Now they're kind of trying a few things. I haven't investigated the whole thing, but I just want to let you know that I think I'm going to be using your product. Thank you
Well,
again.
awesome. That's great to hear.
Yeah.
Yeah, thanks, guys. Have a nice day.
You too.
Question,
Okay.
Paul.
Thanks.
Sorry. Is there a
Oh,
way
yeah,
we
sure.
can contact you for assistance? Like for when I try to download it, it usually crashes. I don't know why.
Is it your laptop?
When you
Yeah,
try to
like all the
download it,
files don't like it tells me I'm missing something when I download. I'm not sure.
are you trying to do it right now? Can you happen to share your screen? Maybe.
I didn't do it right now. Like I already deleted it and tried to play with another program, but I would like to use this. So
I wonder, Paul, if you guys have any help desk for students. Not
Yeah,
that
let me
we.
ask Darius about that because I'm not,
Okay.
especially specifically even my own customers. I don't really deal with the licensing and stuff. The download of some of the downloads I'll help a little bit with, but like the licensing and that sort of stuff can get a little tricky. So maybe Darius has somebody specifically that can help with like downloading the student version and
Yeah.
whatever. So can you maybe shoot
Darius.
shoot
Yeah.
an email to him or
Yeah.
something? Yeah, we
Okay.
can request.
Also, I don't know who the student is. If you don't mind, just what you can do as a student, you can also email them, see if there's like not all of you, just maybe you, and maybe you can get back to me. While I'm going to be also asking Darius if there's any help support for students. Usually they don't. Other softwares don't. So I don't know if you guys have that or not, because they don't want to deal with thousands of people just trying to learn the software. Though I think it would be useful for the company as well.
I know they
Because
have some forms and things where people will answer
okay,
questions.
yeah,
I don't know if it's like a live
that would be
support,
great.
like a customer
Yeah,
will, get on a
yeah.
Zoom call or whatever. But I know there's like student forms that you can ask a question and somebody will get
Oh, that
back
would
to
be
you.
great. Yeah. Okay,
I think
I'll
there's an
speak to
Altair community.
Darius. On the other
Yeah.
hand, you students, I think if you guys have questions, maybe the general help desk within the company, they have web